All right, so like I said, shh, boys, we are starting the Magic X today. We are looking at factoring. So as we do this, this is a technique or a trick that helps us factor as our factors become larger, messier, or more complicated. So what we're learning today are two techniques that will help us factor more complicated problems. The Magic X method. The Magic X method is a representation or a X. So yours are kind of circular because that was the only way I knew how to make them on the Microsoft Word. But the Magic X is technically just an X, sometimes called the diamond problems, where we have the product of two numbers up top and the sum of those two numbers on the bottom. So we're always going to be filling in a number X and Y on the sides, where the top is their product and the bottom is their sum. Yesterday we talked about quadratics in standard form. So standard form was ax squared plus bx plus c. In terms of the Magic X, the product is going to always be A times C from our quadratic problem. So in the Magic X, the product is always going to be A times C from standard form, and the sum is going to be the B value So this is always going to hold true. The product will always be A times C, the sum will always be B, and we are finding X and Y. So this time I want you just to see like kind of what the whole process would look like. So if they gave you X and Y, then it would be -3 times 9 to give me my top -27. And -3 plus 9 to give me my bottom value of 6. So it's the two sides multiplied to give you the top, added to give you the bottom. Okay, this is going to be more like what we have in our problems. So you're going to be given the top, given the bottom, and you need to determine the sides. So what two numbers multiply to +12 and add to 7? Good, Sophia? Perfect. So a +3 and a +4 would add to 7 and multiply to 12. Okay, and next, I need two numbers that multiply to -18 and add to -7. So if I have a negative on top and a negative on bottom, that means I need one negative and one positive, and my negative needs to be bigger than my positive. Okay, Nick? So in -9, +2. 9 times 2 gives -18. -9 plus 2 gives -7. Again, we won't see too much of it as we use the Magic X, but if you're given the top and the side, to find this missing piece here, we would divide. So -30 divided by 2 is negative 15. So when you multiply them together, they give you negative 30. And when you add them together, you get negative 13. Negative 10 on top, positive 3 on bottom. So again, if I have a negative up top, I know one of my factors has to be negative and one of my factors has to be positive. Got Sophia? Sorry. Perfect. So 5 and negative 2, where the 5 is my positive and the 2 is my negative, because I need the larger to be positive since the bottom is positive. Now, if you have a negative bottom and a positive up top, that means both numbers have to be negative. Because the only way to add two numbers together and be negative is to have two negatives. And to multiply them together is to have two negatives to get that positive. All right, Nick? Perfect. So a negative 6 and a negative 4 give positive 24 and negative 10. The second trick that we're going to use with factoring is the GCF. Anytime you have numbers that you can factor out or variables you can factor out, you want to factor them out. So what is the GCF? The GCF is a common factor of the terms of the expression. This could be a coefficient or an exponent or both. And just to get an idea, again, I said all of chapter 5, section 3 is on factoring. What does it mean to factor? To factor is a way of rewriting an expression as a product of its factors. It's rewriting an expression as a product of its factors. And again, factoring is a technique we use with quadratics to solve them. So in this first example, we have 6x plus 18. This is a linear expression because the x has a power of 1, so this is not a quadratic. This is linear. The GCF is the largest number that divides into both. So 6 and 18 both divide by 6. Therefore, the GCF is 6. And in factored form, we bring the 6 out in front. And then inside the parentheses, we leave what's left behind. So 6x divided by 6 leaves an x. 18 divided by 6 leaves a 3. I should be able to distribute the 6 back in and get back to my original. 9x minus 81. So again, you look at the 9 and the 81, both divide by 9. So you factor out a 9, leaving x minus 9. X to the fourth and x squared, neither term has coefficients, but if you look, this has 4 x's and this has 2 x's, which means they have 2 x's in common. So we're going to take out an x squared. So if I take 2 x's away from x to the fourth, that leaves behind 2 x's. If I take 2 x's away from x squared, you must leave a placeholder or a 1 in its place. So again, these both have like coefficients of 1. So if you take away the whole GCF or the whole variable component, a 1 tags behind. And then we have 5x cubed plus 15x. Now my GCF is a combination of numbers and variables. So both 5 and 15 divide by 5. This has 3 x's and this has 1 x. So that means you can take out an x. So my GCF is 5x, which leaves x squared. 15 divided by 5 is 3. And I took the x out. So I have 5x times x squared plus 3. So I gave you 2 handouts when I passed them out. 1 handout's your notes, 1 handout's your homework. So you are doing the front and the back of that worksheet I gave you.